Hi, we're the Robotic Knights. We're all from Plainview and we're all 11 years old. My name is Ayush. One of my hobbies is to play video games. I joined FLL because I like to experiment with Lego.
Hi, my name is Arnav, and in my free time I like to play video games and play chess. I joined FLL because I like playing with the Legos.
Hi, my name is Drew, and I love to play video games and play baseball. I joined FLL because I was interested in coding the robot to do tasks.
Hi, my name is Pradyun, and some of my hobbies are to play soccer and play piano. I joined FLL because I like to build and learn new things.
Hi, my name is Rishan. One of my hobbies is to play video games. I joined FLL because I wanted to learn more about engineering and real-world problems, and I wanted to use those skills when I grow older.
Problems in the last mile introduction. Our innovation project is about the last mile. It's called One with One. One box, one van, one house. We were able to research about the last mile by watching helpful webinars, going to reliable websites, and going around the neighborhood and looking for recycle bins. We also spoke to a few people in the industry to get feedback about the last mile.
Our problem is simple. If you have ever ordered online, then you'd probably know that each item comes in a different package, even if everything comes on the same day. There is also a lot of wastage, and it's not good for the environment. A lot of resources are used. There is also a lot of traffic on streets because there are a lot of delivery trucks coming to your neighborhood. It is not safe for inexperienced postal workers because they won't be able to handle a lot of situations. The packages can be very heavy for them to lift. A lot of them do not know how to drive in snow. If there are certain bumps, they might crash into something.
Here are some more problems we researched about the last mile. The first one will be social issues. This is where workers are paid less. They drive too much, which makes them have no breaks to do things they want to do. The second thing will be pollution. When they're driving a lot, it creates pollution, which is not good for an environment. The third thing will be safety in their neighborhood. When there are so many trucks driving to your neighborhood, maybe one of them might crash into the other, and that is not safe.
Solution and solution design. Our solution is to add one step in the sorting center. Instead of randomly placing the items on shelves, we can sort the items for each house. With this, we can make one van for each neighborhood. We can inherit USPS's idea where there is one post office for each town where everything is sorted. This is called the 111.
Here are the benefits for our solution. The first benefit is that it's safer and easier for drivers. Since there's less packages to deliver, there's less driving work, and they have more time on their hands, which means longer breaks and more productivity. And there's less traffic because less drivers are on the road. Then there's convenience for customers because there's less waste to manage from packaging, and there's less interruptions from drivers. There's reduced pollution. There's less trees cut because there's less cardboard used. There's less plastics and other harmful materials used. And there's less pollution from vans because they emit gases. Lastly, there's materials in the economy. People can save up a lot of money from less packaging, and it's also very efficient. Only one trip is needed to do the same work as multiple trips right now.
We added big wheels in the back of our robot to
No. Wait.
No.
Oh, Q&A.
Q&A.
Okay. So, so what you guys thinking? How should they have to organize their sorting at their end so that they can do the just one trip for multiple products? Is there any idea you have?
Well, first, there are already sorting centers in the first mile, so there can be a little bit more shipping so that a lot of packages can be in one area for the same areas, the same destinations. So basically, we'll use the sorting center, and they'll also sort for similar addresses or the same addresses.
Okay.
So
got
like
it.
each house or sometimes each neighborhood.
Yeah, understand. So to reduce the packaging, right? So every package should have some primary packaging, right? But I understood from your this presentation that if there is a multiple products, right? Means single packaging at one place, means if there is one for one box or one package material, and if there are three different products at one trip, how it reduces the packaging material? How it can be reduce the packaging material?
I think I have like a diagram to show like some map here. So right behind the reduce pollution label, it shows that this is one box, and then if there are like 8 packages, which is probably
Okay.
a lot, but
Okay, got it.
There's
So
that.
basically secondary packaging is going to be reduced, not primary. So yeah, that's it. That's two questions I have. Okay.
Okay, so then robot design.
Wait.
robot
that
design.
it?
Robot design is next. Yeah.
But
Yeah.
we didn't. Only Rishan really answered the questions.
It doesn't really matter.
It would be much more.
Aren't we
questions.
supposed to ask questions?
Okay.
Yeah.
You can ask more questions.
And,
you want.
and he's right, like everybody participate, right? Like
Yeah.
not one person. Others also
Yeah.
should
So
answer.
far I have only these two questions on this particular. So
Okay, robot design. Okay. We added big wheels in the back of our robot to increase balance. We also decided to only add 2 attachments for robots based on the missions that we decided. That's all.
We had tried many ways to complete our missions. We figured out that we should only use 2 attachments. There, the forklift and the long arm. The forklift and the arm collapse. This means that there is a state of the robot that is very compact. This helps because since it takes up a small amount of space, we had more space to keep stuff to help our robot.
We have a low base which makes the robot.
There is a problem when doing the unused capacity task. The back part was too high, so the container would fall over when the robot pushed it. We solved the struggle by putting the back part of the robot lower as well as extending it, so now the container does not fall over anymore. The robot can now push accurately.
We have a low base which makes the robot more balanced, so the robot can do its missions easily without failing.
We use the frame in the robot to trap the wires from motors inside the robot, which keeps it neat and organized. We also use this frame as the center to attach to the hub and other accessories. It keeps it balanced and it keeps the whole thing compact and very low. Then we designed a program. It's called Gyro Straight. We use the gyro sensor inside to measure specific degrees that the robot can go to, and it will follow those exact degrees using the gyro sensor. This helps the robot to go accurately in the direction that we want it to, and it helps the robot to correct itself when it goes off track. For example, if something pushes a robot while it is moving, it'll turn and go back to its original path.
Now let's see.
We discovered how to code and use robot parts and motors. Also how to build a strong balanced robot. We learned how shipping works for online purchases.
And it was through
No, it's
tri-
Sean.
Wait, what?
We innovated during the Sears FLO competition by building our first robot, developing new attachments like a frame for wire management and beams and a forklift. We also developed the gyro strike program, which improved the robot's movement.
Impact. By researching about last mile problems with transportation, we suggested a solution to help the efficiency of reducing waste and pollution. The one package, one van, one house. Who knows, maybe our solution will be used someday.
We included everyone into the robot building. First, we split into 2 groups. In the 2 groups, we had to create a robot design. When both groups were finished with their design, we discussed which part should go in the main robot and which should not. We also had to decide which missions would go with our robot. We put our brains together and found out way more than we thought.
We worked as a team when we were doing the FOL Cargo Connect project. One thing that shows we use teamwork is we spent more than 50 hours working with each other. Each of us contributed in our own ways. We each had a part in building the robot, coding, and bringing new ideas to help occurring problems.
We had a lot of fun doing this project. For example, when we went to build these things so that we could do the task, we had a lot of fun building and talking to each other while doing it.
We used a lot of humor while building and designing.